So I promised to show you those questions that were on the most recent provincial exam that came from this chapter. This would be one of them. Which of the following elements is the most reactive? You're asked to check between xenon, barium, cesium, and magnesium. By the way, if you don't like this particular explanation, I stuck a little video link up there on Dynamis as well that kind of gives you a much more graphic representation of it. When you look at something like xenon as an option, you immediately say to yourself, you know what, that is a noble gas. Noble gas. And if it's a noble gas, it has a full octet. What the heck is a full octet? Full octet means octa, 8. 8 electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7, 8. That means it is stable. It doesn't react with squat. It doesn't want to accept electrons. It doesn't want to give up electrons. It's not going to be reactive, right? So, when you look at the other two, barium and magnesium, if you look on your periodic table, which I'm looking at right now, you're going to notice that both of them are alkaline earth metals. They're both in the same family. So it's very unlikely that those are going to be the correct answers because, hey, how would you choose between them? But a better explanation is that they have 2 valence electrons. And if they have 2 valence electrons, they become stable by losing those 2 valence electrons to form 2+ ions. They're reactive, but not nearly as reactive as this puppy, cesium. Cesium is an alkali earth metal, means it has 1 valence electron. Guess what? That makes it very unstable. It wants to desperately lose that electron and become a Cs 1+ ion. When it does that, it has a full electron shell, just like its nearest noble gas. So that would be number 33. Let's move on to another one. Name the covalent compound. Let's get rid of the keyboard here. Go away. Br2O. First thing you do when you see Br2O is you say, you know what? That is a covalent compound. Bromine is to the right of the periodic table, to the right of that zigzag line. By the way, I go back and forth here between the periodic table, but it's just going to take more time. So you always should have your periodic table very, very handy when doing this material because everything refers back to the periodic table. Bromine is to the right of the periodic table line. Oxygen as well. They're 2 nonmetals. If they're 2 nonmetals, you can't name them as an ionic compound because bromine and oxide, that would be naming them as an ionic compound. They're not losing electrons. They're sharing electrons. Bromine dioxide, I mean, if you look at it, oxygen only has 1 atom, so it can't be di, that would be 2. Bromine, Roman numeral 2, that would make bromine a multivalent ion. And if you look on your periodic table, the multivalent ions are the transition metals. Bromine is not a transition metal. So all of these are out the door, and your correct option has to be dibromine monoxide. Again, these prefixes, good idea just to memorize them. The fact that you have 2 atoms of bromine, mono, 1 atom of oxygen, dibromine monoxide. Let's all move to 37. Maybe this one first. What is the formula for the compound tetraphosphorus decaoxide? Again, when you look at this arrangement of possible formulas, notice that they're all covalent. Phosphorus and oxygen, again, are both to the right of the zigzag line on the periodic table. They're nonmetals, so you don't use the rules for ionic naming. Tetra, check your lovely little data booklet. You're going to notice that tetra is the prefix that means 4. Deca is the prefix that means 10. That tells you right there and then that we are looking at P4O10. piece of cake. So, we have done that one. We have done that one. Let's try this puppy. SnSO4 is interesting because an uncovered sample can absorb enough water from air to completely dissolve. The name of this compound is, aha, you know it's going to have something to do with tin, you know it's going to have something to do with SO4. If you are bothered by something like this that has more than 2 elements in it, in other words it's not binary, chances are it's because you're not familiar with that lovely little sheet of polyatomic ions. Poly means many, so more than one. You never mess with these formulas. You take your sheet, they give it to you on the provincial exam, and you use it on every test. It's a polyatomic ion. If you check the sheet, this one is called sulfate. And sulfate, they give you the charge, and the charge is 2-. Tin, on the other hand, check your periodic table, you're going to notice that tin has 2 possibilities. Tin can either be 2+ or 4+. So you have to say which one it is in the name. Sulfate is -2, so guess which tin you're going to have. Tin 2 sulfate. So that would be the correct answer. Nice. Good. Moving on. Which formula represents the compound formed when ammonium combines with phosphate ions? Well, you have to make sure you know what ammonium is in the first place. Ammonium is NH4. So check that sheet of polyatomic ions. You're going to notice that it's the only positive polyatomic ion, has a combining capacity or a charge of +1. Phosphate, on the other hand, is another polyatomic ion, PO4, and it has a charge of -3. So, you can scratch out A as a possibility because you see that both PO4 and NH4 are not the ions that you see there, right? B is tempting because you actually see NH4 and PO4, but if this is -3 and this is +1, that doesn't add up to 0, right? So every compound you ever have in your long-legged life has to add up to 0. This doesn't add up to 0. It has a net charge that isn't 0, therefore it's the wrong answer. Same thing with this puppy. If PO4 is -3 and you have 3 of them, the total charge on PO4 is going to be -9. Charge on ammonium is +1. 1 plus -9 doesn't equal 0. The net charge isn't 0, therefore that's not a possibility, which tells you that this one has to be D. NH4, charge of +1, you have 3 of them. 3 times +1 is +3, and PO4, of course, is -3. The net charge equal 0. Cool. Number 35. Copper 2 sulfide occurs in nature as the dark indigo blue mineral covellite. What is its formula? Well, this, copper 2, tells you you're dealing with the multivalent ion Cu2+. That's what the Roman numeral stands for, right? Sulfur, on the other hand, if you check out your periodic table, sulfur is -2. So, I am thinking that if this is +2 and this is -2, we have the correct answer right there as A. You can check out the other examples, and again, you're going to see for all of these that the net charge does not equal 0, therefore wrong. Okay, I better write that properly here, wrong. We're just about there. The compound represented by the formula BeCl2 is, well, the way I do this one is just looking by maybe a process of exclusion. This is a metal, left side of the periodic table. This is, of course, a nonmetal, right side of the periodic table. You know that you're dealing with an ionic compound. If you're dealing with an ionic compound, you have to use the rules of naming. Beryllium chloride. You would never use prefixes like di, 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 di. So in other words, the only possibility here is A, beryllium chloride. Beryllium is +2, chlorine is -1, but you have two of them. 2 times -1 is -2. That adds up to a net charge of 0. Piece of